clock.
I feel like I almost got this thing. I'm not sure though. We'll see.
They remind you. We remind you from Hewitt, right? And from our own little exercise outside, that if I drop the ball at the same time that I launch this ball at 20 meters per second horizontally, which one would hit the ground first? The same time. So how long is the launched ball in the air? The same as a dropped ball would be.
Yes.
Have you learned already how to find out how long it takes for a ball to fall from rest? 45 meters. Yes. So, 3 steps. For solving projectile launch problems, 3 steps. Number 1, draw. Draw a picture showing the givens and the unknowns. So you can kind of imagine what the problem is actually talking about. Second step. You're going to find the time that the thing's in the air. Now, which component, which direction matters for finding the time that a projectile is in the air? Vertical. Why?
Because we already know acceleration.
Yes, because vertical is the only direction where there's a force, and therefore it's in the only direction where there's an acceleration. And so it's the only one that's going to affect how long it's in the air. So you're going to find the time, and that's going to be from the vertical. Now, in this case, what did I give you vertically?
45
Distance. Yeah, distance. Right. 45 meters. There'll be other times when you'll have a different vertical given, or more than one vertical given. We'll talk about that in a second. But time of the air is always dependent on vertical, because that's the direction the gravity has. Right? And then third, we're going to find the distance, or in some cases, the speed, depending on what I didn't give you. In this problem, we're going to find the distance, because that's what's unknown. All right? Now, so let's do step 2. We already drew our problem. We're looking for this horizontal distance. Let's do step 2. How long is it in the air?
I get there in 3 seconds.
3 seconds. How do I know that?
Because you do 1/2 of that.
Okay.
Initial velocity is 0.5.
Good.
This is 1/2 a times 5.
Excellent. And I'm going to add these 2 subscripts because it's only the vertical initial velocity and only the vertical acceleration that I can watch here, right? It's the whole mixed bathing thing. If I'm working with a vertical distance, I can only use vertical velocities and vertical accelerations. Right? So, as was pointed out, even though this thing's launched 20 meters per second, how much of that 20 meters per second is in the vertical direction?
None.
None. So the initial vertical velocity is 0. So it becomes vertical distance equals 1/2 the vertical acceleration times the time squared. And what am I after?
Time.
Time. So solve for time. And just by doing a little algebra magic, right, I get that t squared is 2 delta y over a in the y direction. So t is 2 delta y over a y, the square root of that quantity. So, what is that? That's 2 times 45 meters divided by 10 meters per second squared. That's 90 over 10 is 9. The square root of 9 is 3 seconds. So it takes 3 seconds to fall 45 meters. That's nothing new. We knew that already, right? go to step 3 and find the horizontal distance. I'm going to use the exact same formula.
Wait, can you just times the time by the initial velocity?
You can in this case, but this is why. Look here. I'm looking for delta x, so it's arranged correctly. What is the initial horizontal velocity?
20 meters per second.
20 meters per second. And how long is it in the air? 3 seconds. Plus, what's the acceleration in the horizontal direction?
0.
0. That's why I can do velocity times time, because that acceleration is 0.
And will that always be? No.
Yeah. Well, in a projectile, yes.
Like if you're throwing it horizontally, it will be a constant velocity.
If it's a projectile, yes, the acceleration horizontally will always be 0.
Right, yeah.
Is a projectile something that doesn't have its own energy? Like a rocket's not a projectile, right? Because it has its own.
Right. It's, strictly speaking, it's the only force acting on it is gravity. So yes, a rocket when it's firing is not a projectile. Okay? Makes sense? Easy enough? And again, we did one problem like that when I was with you, and then you did a couple of questions like this off the video with Paul. So that's easy.